All right, so hi everyone. My name is Boyan. This is, I think, the fourth year in a row that I speak at OpenNebula conference. First time was a lightning talks, but I count that as well. So we've been around this community for a long time, and we know a few of you. But I'm glad to see new faces. So I kind of, at least in my view, there are about kind of half of the people here are new to this community, new to this conference. This year, I'm going to talk about hyper-converged infrastructure, and does that make sense for everyone, and is that what you really need? So a bit about us and me. I'm the chief product of, and I deal with external technology in our company, meaning not the development of the product, but talking to customers, figuring out what they need, translating that into features of the product, or helping our customers kind of deploy cloud infrastructure using our solutions, right? In a previous life, I used to do packet processing and kind of what's now, it wasn't called software-defined networking when we were doing it. It wasn't cool. It's now called software-defined networking. And in a previous life before that, I was doing kind of algorithms and data structures, so like competitive programming and things like that. Our company and product, we do a very fast and efficient software-defined storage system, which is used by private clouds and kind of mobile and web applications and managed service providers and kind of all kinds of cloud situations. Started back in 2011, so we've been around for about 7 years now. And it's a clean slate design, meaning we kind of, when we started this, we sat in front of a whiteboard and drew the design, and that's what became the product. It's influenced by some, well, there weren't, when we started this, there weren't that many influences in this area. There weren't kind of popular scale-out systems. There were some very niche ones. How it's used is mostly deployed with KVM. We do have some customers who use Zen and who use VMware, and it's mostly kind of our preferred higher-level management system, cloud management orchestration system is OpenNebula, but we also have integrations with CloudStack and OpenStack and ONAP and Kubernetes and whatnot, because it's a very fragmented market. There are many people using different systems, and we need to be compatible with everyone, right? And apart from that, apart from being kind of a software vendor, we are also a user of OpenNebula, which tells you really which is our preferred cloud orchestration system, right? So our own testing development environments, as well as some production services we run on OpenNebula. As you can see, there are kind of fairly small OpenNebula clusters with one is like 750 gigabytes of RAM, and the other one is like 500 gigabytes of RAM. So let's define what hyper-converged is. So the two aspects to this. One is the purely technical aspect. In my opinion, if you're running a block storage system on the hypervisor hosts alongside virtual machines, it's a hyper-converged system. And then in kind of more business circles, they would say that it's only hyper-converged if it's delivered by a single vendor as one product number, right? So if you go to, say, Nutanix and you buy a box from them and it includes all the like hypervisor and storage and networking all in the same box, then they would call it hyper-converged, but not if you get the 3 components from different vendors and you integrate it yourself, right? For the purposes of this talk, we'll consider the first kind of the truth, right? So we will not only consider kind of the technical aspects of it, not whether you buy it from one vendor or from multiple vendors, right? So why is it called hyper-converged? So there used to be this thing called converged infrastructure before hyper-converged infrastructure. And the idea behind converged infrastructure is that we would somehow use one network for both our IP traffic and our storage traffic. So converged means it doesn't have fiber channel. It uses Ethernet for storage networking, which is In 2018, this is kind of obvious. It's like not a differentiator. It's not something new, right? But it used to be once upon a time that this was kind of the grand new concept of how we're going to do IT, do converged infrastructure, right? So that's why it's called hyper-converged. It's very kind of a marketing term, but it just means running a storage system on the hypervisors. Right, so when does it make sense to do hyper-converged? Kind of the most obvious case is when you're starting small. If you need to do infrastructure which is fairly compact physically and doesn't cost a lot of money, then you don't want to spend money for compute nodes and then a separate amount of money for storage nodes, right? You just buy 3 servers, and that's all the infrastructure, all the IT infrastructure you need. So kind of the minimal deployment would be something like 3 servers and 2 switches. I mean minimal deployment with high availability. Obviously, you can go to 1 server and then you don't have HA, and that's a different kind of IT infrastructure that we are not used to. And then at the other end of the scale, you have clouds that work at such a scale that anything like when they purchase hardware, anything less than a full rack of servers doesn't make sense for them. Meaning kind of the overhead of writing a purchase order for a single server is too much for the organization. The building block is 1 rack, right? And they say buy racks of storage racks and compute racks and put them in a data center. And at that end of the scale, hyperconvergence doesn't make that much sense, right? So hyperconverged in small scale, there is one exception we've found to this kind of rule of thumb, which is even if you're operating at large scale, if you're building many small availability zones, hyperconvergence again makes sense. Many small availability zones, for example, in the managed service provider space, an MSP may build separate setups, separate kind of isolated infrastructure for individual customers. So instead of having one large platform, they would build kind of a 3-node setup for one customer and a 5-node setup for a second customer and a 4-node setup for a third customer. And in that case, hyperconvergence also makes sense, right? The other kind of axis in this is if you're building new infrastructure, hyperconvergence makes sense. If you're retrofitting, hyperconvergence in a lot of cases doesn't. Retrofit means kind of the usual case would be there is existing compute capacity, existing hypervisors, and they come to us and ask us, how do we add storage to this existing environment without affecting the existing environment too much? Like we don't want to kind of reinstall all the operating systems and do all kind of resource isolation on them and all complex stuff. We just want to plug a storage system into it. So in the retrofit scenario, hyperconvergence doesn't make that much sense, which kind of in Greenfield, so if you're kind of building a new environment or starting a new service, hyperconvergence makes more sense, right? And another thing about hyperconvergence is, in order for this to make any sense at all, you need a very efficient storage solution. What is that? So if you take a storage system which kind of to deliver the levels of performance you need, it takes half the resources of a typical hypervisor host. That's not a good case for hyperconvergence because it's just way too expensive to take the expensive CPU cores of high-end hypervisors to use that for running the storage system. So if you don't have a very efficient storage system, storage software, and if hyperconvergence doesn't make sense, and another thing you need to do in order to guarantee consistent performance of the virtual disks of virtual machines, so consistently good performance of your virtual machines, what you need to do is resource isolation. So you run the storage system and virtual machines on the same host, but you kind of take a few CPU cores and allocate these to the storage system and take a few more CPU cores, sorry, the remaining CPU cores, and allocate these to virtual machines. In our case, it works out to be something like 10% of the kind of compute resources end up being allocated to the storage system, and the remaining 85 or 90% are used for virtual machines. So kind of key point here, if you're doing this, do resource isolation. Otherwise, you get very bad performance consistency. So performance will be good at one time and it will be bad at the next moment. And yeah. So when not to do hyper-converged, so it's in the opposite cases. So if you're kind of scaling at full racks, hyper-convergence may not be the best thing. If you are doing a retrofit in an existing environment, adding storage to it, if you're not just KVM, but you're trying to satisfy multiple use cases with a single storage system. So for example, we have customers who do KVM and VMware and dedicated physical servers from the same storage platform, right? And while they could run the storage platform on KVM hypervisors, they're not too keen on that. It just, they don't like this mixing of different requirements in the same servers, and then things like upgrading in an environment like that, for example, if you need to upgrade the kernel of a KVM host because of a security issue, that takes out a part of your storage system. So it doesn't bring the service down, right? But it's still an effect on the storage system that maybe you don't want to have, right? So this is this point, kind of independence of infrastructure. I don't want issues on a KVM host to affect my VMware hosts, and that's why you don't do hyperconvergence, right? And the last one is administrative boundary issues. So if you have different teams that don't trust each other fully, or different organizations involved, kind of separating these concerns on the same hosts is hard to impossible. For example, a service provider that is giving root access to dedicated physical servers to their tenants cannot run a storage system for all tenants on these servers, right? They need to have a separate storage system that they provide service from to these tenants. A few examples. So this is a kind of a shared hosting example, hyper-converged. They end up with kind of a large servers because they need to keep primary storage and backups in the same servers. This is hyper-converged with multiple storage clusters. It's kind of the multiple availability zones idea that I mentioned. In small public cloud that started initially with retrofit, even though they have like 50 hosts and they do separate hypervisors, separate storage nodes, and the hypervisors are a mixture of different things. In an MSP that initially started Greenfield with about 20 hosts, they ended up doing hyperconvergence. So it's kind of different in different use cases. This is a slide on how you could do that. So there is lots of kind of minute, tiny detail that need to be taken care of in order for this stuff to work well. And there are some kind of recipes and documentation published, and some other is just common knowledge in our industry. And kind of as a conclusion, I think if you're doing this with KVM and OpenNebula, the key point would be work with experts, because working with amateurs is very expensive. Test and measure everything, even things which you consider obvious. So even things like everyone knows this works, it's something to be verified, right? Because you'll be surprised kind of the stuff that doesn't work.